All right, ladies and gentlemen, today we are going to be talking about Lesson 8.4, finding probabilities of overlapping and disjoint events. In Lesson 8.3, we talked about simple probability, which was the probability that one event would occur. In overlapping and disjoint events, we're talking about multiple probabilities. So when we consider the events A and B, when we talk about the probability of them occurring, we're going to talk about them forming a union. So we're going to talk about not only the outcomes of A and B, but of the ones that at the intersection as well. In some cases, you have disjoint events, which are ones where it is simply A and B where the intersection is empty. As you can see here, the probability of A and B, given that there is an overlap, would be the probability of A or B would be equal to the probability of A plus the probability of B minus the probability of A and B, which is the overlap. Now, if the events themselves are disjoint or have no overlap at all, then the probability of A or B will simply be the probability of A plus the probability of B. Now, if you recall, when we talked about this earlier, when you see the word or, like we do in the probability here, we will be adding together those probabilities. So if we take a look at the example that we have here on the screen, it says a six-sided die is rolled. What is the probability that the number rolled is less than 3 or greater than 5? In this case, this would be an example of a disjoint probability. The reason it's disjoint is because there are no numbers that are less than 3 and greater than 5. So in this case, if we take a look at it, the probability of A or B would be equal to the probability of A being a number rolled that is less than 3, which would be 2 out of 6, plus the probability of rolling a number greater than 5, which is 1 out of 6, and that would give us 3/6, or the probability would be 1/2. So the next example that we're going to take a look at here, it is an example that deals with overlapping events. If we take that same six-sided die and roll it, what's the probability of rolling a number greater than 4 or even? So in this case, we actually have all three. So in this case, the probability of A or B would be a number that's greater than 4. Well, there's 2 of those, so it's 2 out of 6, and that's the probability of A. Plus a number that's even. In this case, there are 3 even numbers on a die, 2, 4, and 6. And that's the probability of B. Minus, and here's the overlap, here's the intersection, any numbers that are greater than 4 and even, which in this case there's only one of those, and that's the number 6. So if we take a look at that and add those together, we'd have 2 plus 3 minus 1, which would give us 4 out of 6, or the probability of doing that would be 2 over 3. So now the next example that we have up here is one that deals with light experiments with plants. So it says you're performing an experiment to determine how well plants grow under different light sources. Out of the 30 plants in the experiment, 12 receive visible light, 15 receive ultraviolet light, and 6 receive both visible and ultraviolet. So what's the probability that a plant in the experiment receives either visible or ultraviolet light? So in this type of a problem, ladies and gentlemen, again, we are going to be dealing with the overlap. So again, if we take them in order here, the first probability that we're dealing with is the probability of receiving visible light. So the probability of A in this case would be 12 out of 30. The second one that we have here is just having ultraviolet light. So the probability of B in this case would be 15 out of 30. And the last one that we have here is the probability that they receive both. There it is, the overlap. There's our intersection, A and B, which would be equal to 6 out of 30. So in this case, ladies and gentlemen, again, like we did with our previous example, what we're looking to do here is add the probability of A to the probability of B and then subtract out the intersection. So in this case, we would have 12 out of 30 plus 15 out of 30 minus 6 out of 30. So if we add those all up and subtract out our overlap, we'd end up with 21/30ths, which we would of course simplify down to 7/10. The question comes up once in a while, Mr. Hagedorn, should we simplify those fractions before or after we add? In order to add and subtract, the best way to do it is to leave it with the common denominator. Once you've done the adding and subtracting, then you can simplify your fraction at the end. All right. The next example that we have here, ladies and gentlemen, is the last example in what we would be dealing with as far as the probability of overlapping and disjoint events, and these are known as complements. Okay? When you talk about a complement, you're talking about something that goes along with it. You're not talking about saying something nice to the person, you're talking about something that goes along with it. So when we take a look at this, anytime you're dealing with complements, you'll see the bar that goes above the letter. So the event A bar, called the complement of event A, consists of all the outcomes that are not in A. And the probability of the complement of an event would simply be the probability of A bar is equal to 1 minus the probability of A. The reason that we deal with 1 is the total amount of outcomes that we have would be 100% of our outcomes, which if we think about that in terms of writing it as a decimal, would be 1. Or even writing it as a fraction, it would be 1 whole. So if we take a look again at a standard deck of cards, okay, 52 cards, remember there are 4 suits, clubs, spades, hearts, diamonds, and there are 13 cards per suit, ace through king. So in this case, what we're looking for is a card randomly selected, and in the first event, that the card is not a 7. So with this one, what we're looking for is the probability of A bar. So for this one, we would be looking for 1 minus the probability of A. So in this case, the probability of A would go back to what we're dealing with. The card is not a 7. So the complement to a card not being a 7 is that it would be a 7. So for this one, the probability of A bar would be equal to 1 minus 4/52. Because there are 4 7s in the deck of cards. So if we take 1 minus 4/52, that would leave us with our probability of 48/52, which we would simplify down to 12/13. The next one, the card is not a red face card, would be an example where we are looking for the complement, again, to that. So the card is not a red face card. What we'd have to look for then is that the probability of A bar is equal to 1 minus the probability that it is a red face card. Okay? So in this case, there are 3 face cards per suit, a jack, a queen, and a king. And there are 2 red suits, which would be the diamonds and the hearts. So in this case, the probability for that would simply be 6/52. So again, if we do some quick math here, we'd get the probability of A bar, or the complement of A, would be equal to 46 over 52, which we would simplify down to 23/26. All right. So that's our lesson for today, ladies and gentlemen. As always, if you have questions, please let me know so I can help you out in any way with dealing with our probability of overlapping and disjoint events. Remember to work through your practice assignments that I put along with this for our distance learning. And as always, stay safe and stay healthy, and Lord's blessings on your day.